What are the values for theta that satisfy the equation sine of theta cosine times cosine minus cosine equals 0 for theta greater than or equal to 0 less than 2 pi? Here now the equations. The equation is sine theta cosine theta minus cosine of theta equals 0. Then, as we did in problem 5, let's take cosine as a common factor. So we have sine of theta minus 1 equals 0. Then, as I said, when they are multiplied, so cosine of theta will be 0 or sine of theta will be 1. So here now we have to find all the values that satisfy this equation when cosine of theta is 0 and when sine of theta is 1. To solve it, let's come back to our unit circle that we discussed before. Now then, 0, 1, 0, negative 1, 1, 0, and negative 1, 0. And then, now which angles that's its cosine is 0? Let's remember that the coordinates was cosine of theta, sine of theta. So which angles its cosine is 0? Angle 0. And
it's the x-axis, all the x-axis.
Yeah, so 0 and 180. Sine of theta
360 and 180, but 0 is better.
Sine of theta مش better يا Rose, because the equal sign here is on 0. Not on.
Oh yeah, because it starts with 0.
So then sine of theta is 1. When the angle's sine is 1, it's angle 90. So the values here will be 0, 90, and 180. These are the values that satisfy the equation. In radian, they are 0, pi over 2, and pi. So sometimes you need to solve it as a linear equation. You have to put the theta and or the trigonometric function as in a side and the numbers on the other side. Sometimes you need to factorize it as take a common factor, then solve it as an equation. Each expression equals 0. So here you have to think, how can we solve anyone? Now let's go to number here, these questions here in number 28. The first one, sine of theta minus 1 times sine of theta plus 1 equals 0. Sometimes I can bring it to you like this. Sine squared of theta minus 1 equals 0. For this one here, when you solve it, you can solve it by 2 ways. You can factorize it as sine of theta minus 1 times sine of theta plus 1. It's like x squared minus 1. And when you factorize x squared minus 1, it's x minus 1 times x plus 1. And sometimes you can solve it like sine squared of theta equal 1. You just move sine of theta to the second side. Then, under the square root, and remember, when you have square root of a variable square, yani square root of x squared, it could be positive and negative x. So square root of sine squared 1, so sine of theta, it could be 1 and it could be negative 1. And if you solve it by factoring here, sine of theta, it could be 1, and sine of theta, it could be -1. If you put each expression equals 0. So if you solve it by this way or by this way, you must get the same answer. Is it clear, or shall I repeat it?
Yeah, teacher, just this. We will stop here.
No. Just here.
Okay.
I didn't start. But
Yeah,
just
okay.
here to tell you that if you have it as sine squared of theta -1, how did you solve it?
Yeah, it's clear.
You can factorize it, and then it's equal 0. So the first part will be 0, or the second part will be 0, or that's if you have it as sine squared of theta -1. So sine squared of theta is 1. And all of us know if you have x squared -1 equals 0, and when you say that x squared is 1, so that's mean to solve it, you have to put the inverse of square, which is square root. And when you solve, and now you have to know that square root of 4 is 2. But the square root of x squared, it could be x or -x. It's like the absolute value of x. They are the same. So when you have here square root of x squared, that's mean x or -x. And square root of 1, it is 1. So that's mean we have two solutions here. X is 1 and -x is 1, or you can say x is -1. So be careful.
I think you explained for us this one that if we have variable, we should do it like positive or negative. But if we have number, no, we will make it just positive.
Yeah. So here we have the same in trigonometric expressions. If you have it as sine squared or sine squared -1 as an example, think about it as x. Say that, okay, it's not sine. Imagine that it is x. How can I solve it? Think about it, then change or evaluate or substitute x with sine and continue. Now let's come back to number 28 here. In number 28, we have sine of theta -1 times sine of theta +1. Here now we have two brackets that they are multiplied. When they are multiplied, that means one of them will be 0. So the first part will be 0. And the second part will be 0. Now, when the first part is 0, we solve it as an equation. Sine of theta -1 is like x -1. So x will be 1. So sine of theta will be 1. So to solve it, theta will be sine inverse of 1. Then ask yourself, what is which angles that its sine is 1?
90, I think, 90. And 270.
Only 90.
No, 270, it is -1. No.
Yeah. So this is the first one, it's 90. The second one now. Sine of theta is -1. So theta will be sine inverse of -1. Now, which angle that its sine is -1?
270.
270. So now the two angles, they are 90 and 270. In radian, it's pi/2 and 3/2.
Teacher, can we just in the quiz write it in the degree?
If I'm asking, yeah, but if it's multiple choice and you find the radian, you have to convert it.
Okay. Teacher, should we find another angle, like for the 90, make 360 minus 90 and the other angle, or just this one?
No, see, for the angle for 0 and 1, just look at the axis. But for the angles or the numbers between 0 and 1 or between 0 and -1, look at the quadrants. 0
Okay, teacher, thank you.
or 1 or -1 exactly, look at the axis. If there's a number between them, look at the quadrant.
Okay.
Okay. Is it clear?
Yes, teacher, thank you. But teacher, can you wait just a second to write the answer?
It's okay.
Teacher, I heard that if the domain in the question is given in radians, then the answer I should give should also be in radians. But if, like, for example, they said theta is between 0 degrees and 360 degrees, then I give my answers in degrees.
Yeah, yeah. And sometimes in your book, they ask you on the answer in radian. But to make it easier for you, I just, when we are at school, when I write this answer, or when I wrote this answer, sorry, I let them convert it in radian. But here, Alice, I just stop at the degree.
Okay, teacher.
Okay, but what did you say? It's true, Susan. If they told you that find the answer between 0 and 2 pi, that's mean you have to give me the angle in radian. But if they tell you between 0 and 360, but in degree.
Okay, teacher, thank you.
Yeah. So what did you say?
خلاص, it
Correct.
depends
This
on
is
the
correct.
question.
يعني what Susan says, that's correct. Oh, this what must we do? That we must try the answer in radian. But see, as I told you, sometimes I find the answer in degree and I wrote it in radian.
And
So
teacher,
just
we
here,
actually we can solve everything as a degree. Then the answer we will convert it to radian as we talk.
Yes, exactly.
Yeah.
Now number 29. In number 29 here, we have 2 sine squared of theta minus 1 equals 0. Here now it's like 2x squared minus 1 equals 0. How did you solve it? You put 1 on the other side, divide by 2, divide by 2. So x squared will be half. So x, it could be positive or negative 1 over square root of 2. Other way, some of you could solve it by factoring, like it's a square root of 2x minus 1 times square root of 2x plus 1. And they are the same. Here, we have to do the same steps in sine. Just we have to say that it is 2 sine squared of theta minus 1 equals 0. So 2 sine squared of theta, put the 1 on the other side, divide by 2, divide by 2. So sine squared of theta is half. Under the square root. So sine of theta. Now be careful. If you put it as square root of half only, you will take half of the mark. You solve half of the question. There's an negative half, or negative 1 over square root of 2. So sine of theta will be positive or negative. Then here, as you know before, we have distribute the square root onto the numerator and into the denominator. So it will be positive or negative 1 over square root of 2. That's mean here we have two values. Sine of theta, it could be 1 over square root of 2, and sine of theta could be negative 1 over square root of 2. After we have this now, we need to find the angles. Now, until here, is it clear?
Teacher, we can say square root of 1 also, like square root of 1 over square root of 2. It's the same, right?
Yeah, the square root of 1 is 1.
Yeah, okay.
By now, is it clear?
Yeah.
Yes, teacher.
Okay. So now, Let's solve now these two small equations here. Sine of theta is 1 over square root of 2 and negative 1 over square root of 2. Let's remember now our unit circle that if we have here
I think for the sine it's 45.
one of them is 45, yes.
Yeah, 1 over.
Then sine of theta is 1 over square root of 2. So which angle that its sine is 1 over square root of 2, which is 45. One of them is 45. So then when now where the angles its sine is positive, it's in quadrant 1 and quadrant 2. So one of them is 45, as we said, and the other one, since it's in quadrant 2, we have to start from the negative x-axis then rotate with 45 degrees in the quadrant 2. And here, it's rotate from the negative x-axis 45 degrees. Now we need to find these two angles. The first angle, it's 45. And the second angle, here, we need to find its measure. Which is 90 plus 45, which is 135 degrees. So we found now two angles. We need now to solve which angles that its sine is negative 1 over square root of 2. Sine is negative, so I am in quadrant 3 and quadrant 4. Then I have to rotate 45 degrees from the x-axis and positive or negative, such to rotate in quadrant 2. So here now, we are, I need to draw my angle in quadrant 3. I need to rotate now 45 degrees. So one of my angles are rotate 45 degrees from the negative x-axis. But in order to find its measure, we need to find the measure, its measure starting from the positive x-axis. This one. Which is 180 plus 45, which is 225. And then the sine is also negative at quadrant 4. So we need now to draw the sine here and then start rotating from the positive x-axis 45 degrees to stop at quadrant 4. And the angle here is 45. But I need to find its angle starting from the positive x-axis counterclockwise to reach this angle. So here, starting from the positive x-axis counterclockwise to reach this point, which we have to say it's 270 plus 45, which is 315. Yeah. So how many angles here we have for the answer? We have 4 angles: 45, 135, 225, and 315. Let's remember now how can we write the answer in radian. (45), we know that it's pi over 4. 135, I want it's in pi, so pi.
I will make it
by
multiply by pi over 180.
180. In other words, let's divide 135 by 180, which is 3 over 4. Now in calculator, if you divide 135 times 180, they give you the answer as 3 over 4. So that's mean it's a 3 over 4 times pi, and 3 pi over 4. So in radian, you have the angles as pi over 4. 3 pi over 4. Then 225 times pi over 180. Let's divide 225 over 180, which the answer is 5 over 4 times pi, which is 5 pi over 4. And the last one, we have 315 times pi over 180. So 315 by 180, which is 7 pi over 4. So the angles in degree, they are 45, 135, 225, and 315. And the angles in radian, they are pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. Is it clear?
Yes, teacher. Teacher, I just confused in one thing. When I want to write like the 45 or 60 or 30, like I confused like where to write them exactly. Like
Well,
the 45, it will be like from the 90 or from the 0, or like I confused between them. Can we just like draw them again without anything, like just to see them? Like just like to draw the 45 and 60 and 30 in each coordinate, like to see where is it.
now, number 30 here. In number 30, we have tan of theta equals tan squared of theta. Here now, we cannot say can teacher, we can cancel tan with tan. This is wrong. And such as if you have x equal x squared, you cannot say teacher, I will cancel x with x, so I have x1. This is wrong. Here, just take, I'll put tan to the other side, so I have it as tan squared of theta minus tan of theta equals 0. Then we take theta as a common, tan of theta as a common factor. Then tan of theta minus 1 equals 0. So tan of theta, it could be 0, and tan of theta, it could be 1. Now, as I told you, if I'm asking you about angles, its theta is 0, you have to find now the inverse. Now, which angles that's its inverse? Oh, its tan inverse is 0. Of 0 is theta. Now, the angles that its tan is 0, that means its sine is 0. Because as we know before, tan is sine over cosine. Now, tan of theta, yani sine over cosine. So, when tan is 0, that means the sine is 0. So,
And the cosine is 1.
it could be 1, yeah. So, which angles now its sine is 0? 0 and 180, is it right?
0 and 180, yeah.
So 0 and 180. Now, which angles that its tan is 1? Do you remember now which angle its tan is 1?
I don't think we have done this one.
Tan is 1. That's mean the sine of the theta equal its cosine. So which angle? Its sine equal its cosine.
Teacher,
45.
actually, from what we
45.
wrote,
Thank you.
have it.
So one of the angles is 45 because the sine of 45 is 1 over square root of 2 and its cosine is 1 over square root of 2. So its tan is 1. And one of them is 45. But I need to find now the second angle. In which quadrant the tan is positive? In quadrant 3. I said it's 45. So I'm start to rotate from the nearest x-axis with 45 degree. So the angle now from this axis to this line is 45 degree. But when I need to find the angle as it's when I need to find the measure of the angle, I need to start rotating from that initial side in the positive x-axis up to this line. So that's mean it's 180 plus 45, which is 225. So now the angles that its tan is 1, 45, and 225, and the angles that its tan is 0, 0, and 180. These are the angles. So the solution: 0, 180, 45, and 225. In radian, they are 0 by over 4 and 225, which is 5 by over 4. These are the angles now in radian. Is it clear?